The largest predatory shark alive today, the great white, can hit over 20 feet long, with bone-crushing jaws and serrated teeth made for tearing flesh. That alone is enough to clear a beach. Now rewind the clock hundreds of millions of years before modern sharks evolved, to an ocean that was still testing what a shark could be. Teeth arranged in bizarre patterns, jaws that sliced more than they bit, bodies that broke the rules of what we think a shark should look like. Some were built for speed, some for ambush, and some just looked wrong in a way that makes them unforgettable. In this video, we're looking at 5 of the most interesting prehistoric sharks we know about from fossils, how big they got, how their teeth actually worked, and what it would feel like to share the water with them. By the end, you'll see just how tame modern sharks look compared to some of their ancient relatives. Let's start with the one that looks completely made up. Helicoprion, usually called the buzzsaw shark for obvious reasons. This was a large, shark-shaped cartilaginous fish that lived during the Permian period, roughly 290 to 270 million years ago. Fossils of it have been found in what's now North America, Russia, Europe, Asia, and Australia, which means this thing wasn't some one-off oddball. It was swimming in oceans all over the world. Let's talk about the weirdest part of Helicoprion, its teeth. Instead of normal rows of teeth, it had a tooth whorl, a spiral of teeth all fused into a single coil. New teeth grew in the center as the animal aged, and older teeth got pushed outward, building this buzzsaw-shaped spiral. Some whorls held well over 100 teeth. For a long time, nobody could even agree where this spiral went on the animal. Early scientists tried putting it on the upper jaw, on the snout, even on the dorsal fin as some kind of weapon. The problem was that the rest of the skeleton was cartilage and almost never fossilized, so all anyone had was the spiral by itself. That changed when a really good specimen from Idaho turned up with bits of jaw cartilage still attached. When it was CT scanned in 2013, it finally solved the mystery. The tooth whorl sits in the lower jaw, right at the front, braced by extra cartilage and packed in front of the jaw joint. So when Helicoprion closed its mouth, that whole spiral of teeth rolled backward inside the jaw instead of just snapping shut like a normal bite. So how does a shark like this actually eat? The simplest way to picture it is like a moving saw or conveyor belt of teeth. As the jaw closed, the front of the spiral would grab and pull food inward, and the rest of the whorl would keep dragging and slicing it deeper into the mouth. That setup works really well on soft-bodied prey like squids and other cephalopods, and likely helped it tear the soft parts out of shelled animals such as ammonoids and nautiloids. And even though everyone calls it a shark, technically it sits in a different branch of the cartilaginous fish family tree, closer to modern ratfish and chimeras than to great whites. From the outside, though, it probably looked like a fast, open water shark with one major design twist. Instead of multiple rows of teeth, it had a buzzsaw built into its lower jaw.
Next up is Edestus,
The one people call the scissor-toothed shark. This was a large, shark-like cartilaginous fish living in the late Carboniferous, around 313 to 307 million years ago, in tropical seas that covered parts of what are now the United States, the UK, and Russia. The biggest species, Edestus heinrichi, is estimated to have reached over 6.7 meters, roughly the size of the largest great white sharks, and may have been the largest marine predator on the planet at that time. Like Helicoprion, Edestus was part of the eugeniodont group, relatives of modern ratfish and chimeras. Its interesting tooth anatomy has also given it a spot on our list today. Instead of normal rows of teeth, each jaw only had a single curved blade of teeth running down the middle. The upper jaw had one tooth blade. The lower jaw had another. Put together, they looked like a pair of gigantic pinking shears loaded with triangular, serrated teeth. New teeth grew at the back of each blade. Older ones got pushed forward, and eventually, the front teeth were literally ejected off the edge. Over the animal's life, each whorl could cycle through dozens of teeth. For a long time, nobody knew what to do with that. Early on, people seriously suggested these things might be fin spines or defensive blades on the dorsal or pectoral fins, because the jaws just didn't make sense. Even once fossils turned up with the blades clearly attached to jaw cartilage, the questions stayed the same. How does a shark like this actually bite anything? One line of research looked at microscopic scratches on the teeth and suggested Edestus might have attacked by thrashing its head up and down, using those forward-projecting teeth to slash prey vertically and rip them up before swallowing them whole. More recently, CT scans of a beautifully preserved skull, nicknamed Ed Head, showed something even stranger. The jaws had a two-gear system. As Edestus closed its mouth, the upper and lower tooth blades snapped together, and the lower blade slid backward toward the throat at the same time. In other words, it didn't just bite down, it bit and sliced, using the blades like a moving pair of scissors. Modeling suggests that during a bite, each tooth could slice through prey multiple times its own length, and the jaw mechanics gave it a serious, concentrated bite force. Put that all together, and you get a shark-like fish whose main strategy was to snap prey in half, taking big, meaty chunks out of other fish or soft-bodied animals like ancient squid, and then scooping up the pieces. Thankfully, nothing alive today feeds quite like that. This interesting feeding design definitely earns Edestus a spot on our list. Time for shark number 3, Stethecanthus, who swam around the ocean with the anvil on its back. This was a small, shark-like cartilaginous fish that lived from the late Devonian into the late Carboniferous in oceans across what's now North America, Europe, Asia, and Australia. In most ways, it looked like a fairly standard early shark until you get to its back. Adult males had one of the strangest features in shark history: a flattened, ironing board-shaped first dorsal fin with a bony spine and a brush on top, together called the spine brush complex. The upper surface of this anvil and the top of the head were covered in big, tooth-shaped scales, denticles. On the anvil, they point forward. On the head, they point backward. So if you look at it from above, it almost reads like a fake giant mouth pattern sitting on its back. What was that for? We don't know for sure, but a few ideas keep coming up in the science. Because it's only confirmed in sexually mature males, it may have been used in courtship or mating. The matching denticle patches on the head and anvil may have mimicked a huge open jaw to make the animal look more intimidating to predators. Whatever the exact function, it definitely wasn't hydrodynamic. That whole structure would have created drag, so Stethecanthus was probably not a fast pursuit hunter. Its overall build and teeth back that up. Compared with other sharks of similar size, its fins and teeth are relatively small, and its weird dorsal crest would slow it down. So it's thought to have been more of a bottom-oriented predator, cruising shallow coastal waters and feeding on small fish, crustaceans, cephalopods, and other invertebrates. Fossils from places like the Bear Gulch limestone in Montana suggest it may have been migratory, returning to certain areas to mate and give birth, the way many modern sharks do. So while our other sharks are interesting because of their jaws, Stethecanthus makes this list because of its silhouette. A little shark with what looked like an anvil covered in teeth stuck to its back. Time for shark number 4. Cladocellatia, the scaleless speed shark from the Devonian. This was a shark-like cartilaginous fish from the late Devonian, around 370 million years ago, known mainly from North America. It had a very modern-looking outline for something so old. A streamlined, torpedo-shaped body, big pectoral fins, and a deep, crescent-shaped tail, a lot like a mako or great white. Those keels along the tail stalk and that lunate tail are classic high-speed open-water hunter features, and fossils from the Cleveland Shale even show prey preserved inside it, mostly small ray-finned fish, arthropods, and eel-like conodonts, often swallowed tail first, which fits with it chasing down fast-moving prey in the water column. The reason Cladocellatia is on our list, though, is that it breaks some of the rules we expect for sharks. Unlike modern sharks, which are wrapped in tough, drag-reducing skin denticles, Cladocellatia was almost scaleless. It only had tiny denticles around the mouth, eyes, and fin edges. The rest of the body seems to have been basically smooth. No heavy armor, just a slick, lightweight body and powerful tail doing the work. Its teeth were cladodont style, a big central cusp with smaller side cusps, good for grabbing and holding rather than sawing chunks off. And many fossils show teeth worn from long use, so it didn't cycle through endless, fast-replacing tooth rows the way modern sharks do. The fossils are also ridiculously good. We don't just have tooth bits. We have full body impressions with traces of cartilage, muscle blocks, and even internal organs like kidney-like structures and twisted gut contents. That makes Cladocellatia one of the best windows we have into what early sharks were actually built like, inside and out. And to make it weirder, we have no clear evidence of claspers in this animal, even though they're present in many other early sharks. So how it reproduced is still an open question. Cladocellatia makes our list today for a few reasons. Its interesting look into the world of prehistoric sharks, and that it had basically no scales or dentical armor plates, just thin, fragile skin. And finally, we couldn't make a prehistoric shark video without mentioning the most well-known of them all, Megalodon. Megalodon lived much more recently than the other sharks we've talked about, cruising Earth's oceans from about 23 to 3.6 million years ago, in the Miocene and Pliocene. It showed up almost everywhere except the poles, with fossils from Europe, the Americas, Africa, Australia, and New Zealand. Young megalodons seem to have grown up in warm, shallow nurseries close to shore, while adults spent more time in deeper coastal and open ocean waters, following herds of whales the way today's big predators follow migrating herds on land. Size-wise, this thing is ridiculous. The largest estimates put big females around 50 to 60 feet long and tens of tons in weight, roughly 3 times the length of a large great white and heavier than a loaded city bus. And nearly everything we know about it comes from teeth and a few sets of vertebrae. Those teeth are where the name comes from. Megalodon literally means big tooth, and they absolutely deliver. Up to 7 inches tall, thick, heavily serrated, and packed in jaws that may have been around 3 meters, 9 to 10 feet, across, with more than 250 teeth in multiple rows. Models of its bite force land around 40,000 pounds per square inch, several times stronger than a T-Rex and orders of magnitude beyond anything humans can do. What's especially cool is that it wasn't just a giant great white copy-pasted and scaled up. Modern research puts Megalodon in the extinct otodontid lineage, more closely tied to ancient mackerel shark relatives than to great whites. It probably had a torpedo-shaped, lamnid-style body, built for steady cruising rather than insane sprint speed, with huge pectoral fins and a powerful tail. Chemical clues from its teeth suggest it was at the absolute top of the food web and didn't specialize much. More of a, if it swims, it's food, generalist. Evidence from bite marks and coprolites, fossil poop, points to a menu that included small and large whales, seals, sea cows, turtles, big fish, and other sharks. And in some whale fossils, you can literally see megalodon teeth still embedded in the bone. For all that power, it still wasn't untouchable. As oceans cooled, sea levels and currents shifted, and the mix of marine mammals changed, the smaller coastal whales, Megalodon seems to have favored, declined, while some competitors, like early killer whales and modern great whites, were better suited to cooler, changing seas. By around 3.6 million years ago, it disappears from the fossil record. And no, despite movies and clickbait, it's not secretly lurking in the deep. A predator that big, that warm-blooded, eating that much, would leave obvious traces in today's oceans. So Megalodon makes the list not just because it's the big one, but because it represents the peak of shark super-predators. A giant, wide-ranging, warm-bodied hunter that could bite whales in half and shaped an entire marine ecosystem. Thanks for watching. The prehistoric oceans gave us some of the strangest sharks in Earth's history, from strange teeth to interesting body plans. Each one helps us understand more about the world before us. If you enjoyed this video and want to learn about more amazing creatures, make sure to like and subscribe for more episodes on prehistoric life and the animals that ruled the oceans before us. And if you want something to watch next, check out our recent video on the top 5 largest prehistoric crocs, or our recent video about the 80-foot marine predator Ichthyotitan, to learn about other apex predators that shared these ancient seas.